In this video, I'll introduce my new split ring gear, MK2. I'll demonstrate how it works and conduct some tests to assess its strength, such as pulling this stack of wood. Before we dive into the strength tests, let's first understand how a split ring gear functions. The first stage consists of a planetary gear system, where the planets revolve around a sun gear. The second stage is driven by the movement of these planets. Let's take a closer look at the details. To calculate the gear ratio of the first stage of the planetary gear, we divide the number of teeth of the blue ring gear by the number of teeth of the orange sun gear and then add 1. In this example, that's 1 plus 69 divided by 15, resulting in a total ratio of 5.6. Let's see this in action. The sun gear rotates a total of 6 times, and the planets make 1 full revolution and a bit more, since the sun gear completes 6 turns rather than 5.6. Next, we calculate the ratio of stage 2, the number of teeth of the stage 2 ring gear divided by the number of teeth of the stage 2 ring gear minus the stage 1. In this case, the upper stage has 72 teeth and the lower stage has 69. This gives us a gear ratio of 24. In total, the combined gear ratio is 5.6 multiplied by 24, which equals 134.4 to 1. Now, let's observe the movement in the second stage. As the sun gear makes 6 rotations, the planets complete about 1 full revolution, while the second stage moves only a few centimeters. Having understood how it works, let's take a look at the construction of the gear. Inside the ring gear, we have steel balls with a 3mm diameter, and a groove ball bearing is used for the sun gear. The sun gear in the MK2 version features new cutouts in the center, and at the ends to accommodate new ball bearings that reduce friction. Furthermore, it can now be secured onto the motor shaft with an inserted nut. To install it, place the sun gear onto the motor, and then weld the nut down as far as possible. After that, it can be positioned into the ball bearing within the ring gear, allowing you to align the planets around it while ensuring even spacing between them. I also tested 2 backlash settings, one at 0.05 millimeters and another at 0.14 millimeters. The less backlash there is, the less play the planets have, which results in a more precise gear. In the second stage, there are cutouts designed for the groove ball bearing that fits perfectly onto the sun gear. Inside the gear housing, 6mm steel balls are pressed in, along with a large groove ball bearing. Using inserted nuts, all the components are securely connected, including the motor mount and the rear side of the assembly. For the gear output, I utilize larger inserted nuts as shown here. The gearbox housing is then simply placed on the 2 prepared stages. These 2 parts are connected using 20mm long bolt screws. At this point, the sun gear should rotate smoothly and the output should turn slowly. The motor mount has also been improved in the MK2 version of the gear. In the MK1, the motor was directly screwed onto the ring gear from the inside. However, in this version, a motor mount is first attached to the rear side of the ring gear. All parts are held together with bolt screws. Additionally, a bolt screw secures the motor shaft to the sun gear. Now, let's run some tests to evaluate its strength. I mounted the gear onto a small wooden structure, and, to simplify things, I printed a winch. For the first test, I set up my force gauge, a rolling board, and the winch. Next, I installed a small test rig featuring my Raspberry Pi, an encoder, and a power supply. To begin, let's examine these 2 wooden logs. The gear successfully pulled a maximum of 5 kilograms, so I decided to increase the weight. The gear was able to reach a force of 12 kilograms before abruptly stopping. It turned out that my counterweight, made of a concrete sack, wasn't sufficient. As a result, I set up a final test with an adequate counterweight. The force gradually increased, reaching about 20 kilograms. At 24 kilograms, the motor began to vibrate, indicating that this was the maximum force achievable. Thanks for watching. Don't forget to subscribe to the channel.